Welcome for today's tutorial. Today we're going to look at calculus, and this calculus we're looking at the branch of calculus which is integration. Let's look at how to solve question on integration and also evaluate some complex question. And let's look at we have two branches of integration, the indefinite integration and then the definite integration. Now let's look at indefinite integration. Now in indefinite integration, we can integrate a function when we have a function of x to the power of n dx. For us to integrate this function, we apply the method which is what? X to the power of what? N, right? Which is the power. Then add 1 to the power and then also bring down the power, also add 1 plus the constant of integration. When you see a question in this form, you know that it's indefinite integration because it does not have a limit, the lower bound and the upper bound. So in this kind of integration, we apply this method by adding 1 to the power and also divide the power and also add 1 to the power at the denominator. This kind of integration is called the indefinite integration. You know that in differentiation, we solve question by subtracting 1 from the power, and we know that integration is the reverse of differentiation. That's why in this integration we add 1 to the power, whereby in differentiation we subtract 1 from the power. Now look at how to solve question on this integration. Let's look at example 1. Example 1. They say you should evaluate the integral of what? 2x cubed dx. Now, for us to be able to evaluate this kind of integral, you know that we are going to add to the power and also divide by what we did on the numerator power. So we are going to have this is going to be what? 2x to the power of 3, right? You know that in indefinite integration we are adding what? 1 to the power, right? Which is plus 1. And then we bring down the same power, which is 3 here, and add 1 to the power, right? Then we introduce what? A constant of what? C, which is constant of integration. Now we are going to have this become what? 2x, 3 plus 1 is what? 4, right? All over. 3 plus 1 is what? 4, right? Plus what? C. Now if you look at this guy, you know that 2 can go into 2 one time, right? 2 go into 4 how many times? 2 times. So we're going to have x raised to the power of 4 all over 2 plus c, and this is the final answer. This is how to evaluate this kind of question using what the indefinite integration method. Now let's look at example 2. In example 2, they say we should evaluate the integral of what? Bracket 2x squared plus 3x dx. Now if you look at this question, you know that we're going to integrate them one after the other, right? Let's look at how to solve it. Solution. We have the integral of what? Bracket 2x squared plus 3x, right? Dx. Now this becomes what? When we are integrating, we remove this integral sign, then we have 2 here, right? Then x is power of 2. You know that in integration we are adding 1 to the power, right? So this x is power of 2, we introduce what? Plus what? 1. Now divide by the same power, which is what? 2. Then also add it with what? Plus 1 at the denominator. Now we are done with this kind. Plus the second one we have for 3, right? 3x. I know that this x have an invisible power of what? 1, right? Since in integration we are adding 1 to the power, we add it what? Plus 1. What we did on the the upside, you are also going to do what on the downside, which is 1 plus what? 1. Now, at this point in time, we introduce our constant of what? Integration, which is what? C. We add C to be a constant of integration because the integral does not have a band, does not have a lower band and an upper band. That's why we add what? A constant of what? C, which can be any numbers. Now let's look at it. Now we are having what? This becomes what? 2, right? X. 2 plus 1 is what? 3, right? All over. 2 plus 1 is what? 3. Plus, we have what? 3, right? X to the power of what? 1 plus 1 is what? 1 plus 1 is 2, right? All over. 1 plus 1 here is what? 2. Plus our constant C, which is what? The final answer. This is how to integrate this kind of question. Now look at example 3. Example 3. So you should evaluate the integral of what? 5 dx. Now, for us to evaluate this integral of 5 dx, know that this 5 does not have a constant of what? X. And since it's a constant, in integration we add what? The value we are integrating respect to the constant. So this is going to be what? 5x plus what? C, which is a constant of integration. This guy is a constant. A constant is any number that does not have a value, a variable in which we are integrating respect to. Since this guy does not have the value of x that we are integrating respect to, we multiply by what? The variable of what? X. That's why I have 5x plus c. You know that in differentiation, when we differentiate a constant is 0, right? But in integration, when we integrate a constant, it gives us the value that we are integrating respect to. That's we multiply the value we are integrating respect to. That's how we get in integration. That's why this guy becomes what? 5x. Then plus our constant of integration. Now let's look at example 4. Say we should integrate 2x dx. Now if you look at this guy, you know that 2x is what? This is going to give us what? 2x. X is just the power of 1, right? Then we add 1 to that power of that. Going integration, we're adding 1 to the power. Then also divide by that power. Add 1 to it. This upper also bring it to the downside. Then plus what? Our constant of integration. Now this become what? This gives us what? 2x. 1 plus 1 is what? 2. All over. 1 plus 1 is what? 2. Plus our constant of integration, which is c, right? Now this 2 cancel out this 2, right? We are going to have what? S squared plus what? 1. This is our final answer. And this is how to integrate. Thank you very much. Okay, now we're looking at definite integration. What does it mean? Definite integration, when we have the integral of f of x, the x. For definite integration, this will be what? F of b minus what? F of what? A. I will explain this formula for us as we are going to solve the question on definite integration. Now look at example 1, how to solve question on definite integration. Now for example 1, they say we should evaluate the integral of 3x squared plus 1 dx as the integral tends from 0 to what? 2. Now if you look at this type of integration, see that this integration have what? A time band. You have a limit, which is the lower limit and the upper limit. Since this integration have a limit, we call it a definite integration. And now for us to be able to solve this kind of integration, we evaluate it. After evaluating it, we substitute the power, the upper power into the function. Then we subtract the lower power into the function also. Let's go ahead and solve it now. Solution. Now we have the integral of what? Bracket 3x what? Square, right? Plus 1 the x from 0 to what? 2. Now this becomes equals to what? Let's integrate this function. You have 3 here, right? X to the power of what? 2. You know that the integration by adding 1 to the power, right? So plus 1 to this power. Then you bring that power and the plus 1 down also, which is what? 2 plus what? 1. We are done with this one. Then plus, this is 1, right? 1 is a constant. It does not have the variable of x attached to it. Since it does not have the variable of x attached to it, we integrate, as I integrate with respect to s, you just put what? X. If you are integrating with respect to t, you just put t there. If you are integrating with respect to w, you put w here. Even though this is 1, 2, or 3, or this thing, since it's a constant, just put the variable at that particular point where the constant is. That's why I'm putting x here. Then we are done. Then you know that the power start, this is the lower bound, right? From 0 to what? The upper bound is what? 2. Now if you look at this guy, you know that in indefinite, the definite integration, I did not add the constant of what? Integration, which is what? Plus c. Because it has a time band, which is from the lower limit to upper limit. That's why I did not put what? Plus c. So don't pay attention to this guy. In indefinite integration, we add the constant, which is what? Plus c, because it does not have a time band, which is the lower band and the upper band. So now if I have to evaluate this guy, now we're going to have what? This becomes equal to what? We have 3, right? X. 2 plus 1 is what? 3, right? All about what? 2 plus 1 is what? 3, right? Plus x from 0 to what? 2. Now that we already evaluate the integral, what we are going to do next is to apply this formula. Our b here is what? Here our a is what? The lower band, which is what? 0. The downside is our a. And our b is what? The upper band, which is what? 2. So when you see this formula, it's telling us that after we evaluate the integral, then we substitute the value of the upper band into the integral, the entire integral, and then subtract by substituting the lower band into what? The entire integral. So let's continue. Now we have what? We have 3x cubed, right? Sorry, we have what? This guy, 3x cubed, right? All by 3 plus x bracket plus 0 to what? 2. You know that this 3 can cancel out this 3, right? So we are going to write with what? X to the power of 3, right? Plus x, and it turns from what? From 0 to what? 2. From 0 to 2. Now by the formula, you know that we have what? If by the formula we have f of b, right? Minus f of what? A. So our b is what? Is 2, which is the upper band, and our a is what? Our a is what? Our a is what? 0, which is the what? Lower band. So what this means is that we should substitute the value of b first into this function that I already integrated. So I'm going to have, when you put 2 here, when you see s, you have what? 2 raised to the power of what? 3 plus, put 2 here, you have what? 2, right? We are already done with the upper band. Then you subtract it, which is this guy. You put the value of our a, which is 0, into the function again. So we're going to have 0 raised to the power of 3, right? Plus, when you see s, you put what? 0, right? Now we are done. Let's expand it. 2 raised to the power of 3 is what? This is going to give us what? 8, right? Plus 2. Minus 0 raised to the power of 3 is what? 0, right? Plus 0. So that's what I have. This becomes what? 10 minus what? 0 plus 0 is what? 0. So our final answer becomes what? 10. This is how to evaluate a definite integral that have lower band and upper band. Now let's look at example 2 before we move to the next topic under integration. Example 2. Say we should evaluate the integral of 2x squared minus 3x dx from 0 to 1. Now, if you look at this integral, it is called a definite integral because it has what? A lower bound and an upper bound. So let's look at how to solve this down. Solution. Always remember this formula that the integral of f of x, the x is equal to what? F of b, right? Minus f of what? A. After we integrate the function here, we substitute the power, the upper bound into the function, then we subtract by substituting what? The lower bound here into the function that I've already integrated. That is what this formula means. Now look at how to apply it. Now, let's evaluate this guy first. We have what? 2x to the power of 2, right? And in integration, we're adding 1 to the power, right? Which is what? Plus 1. Now, 2 is power of 2 plus 1. We're also going to bring it down. We have 2 plus what? 1. Then we are done with this guy. Minus 3 here. X. Note that this x has an invisible power of 1 by the law of indices. Because anything raised to the power of 1 is the same thing as that variable, right? Or that number. So we have an invisible power of 1 here by the law of indices. And you know that in integration we're adding 1 to the power, right? Which is what? Plus 1. Also bring this 1 plus 1 down. Now, you know that this is what? Definite integration. We are not going to add plus c. Because it has what? A time bar, which is from 0 to what? 1. So we just close it and put our time bar, which is 0 to what? 1. Now, at this point, let's expand it. We have what? 2x. 2 plus 1 is what? 3, right? All over. 2 plus 1 here is what? 3, right? Minus, this is 3, right? X. 1 plus 1 is what? 2. All over. 1 plus 1 is what? 2. Then we close the bracket, put our lower bound here and our upper bound. Now, by this formula let us know that you should put the value of what? The upper bound first into the function that I already evaluated. The upper bound here is what? The one that is on top. The lower bound here is the one at the down. So don't make mistakes. Sometimes this can be 0 and this can be 1. But what you are going to do is to put the power that is on top first into the function that I evaluated. So I will have here, this becomes what? Anyway, you see x, you put what? First put your upper bound 1. This is power of 3. All over 3 minus 3. This is what? X, right? Anyway, you see x, you put what? 1, right? This is power of 2. All over 2. We are done with substituting the upper bound into the function. Now, pay attention. If this guy was 0 and here was 1, what you're going to do is to first put 0 into this function. But since this guy is 1 first at the up, then put the value into what? The function, which is this guy now. Then you put what? Minus. By the formula, minus. Now you substitute the lower bound now into the function again, which is this function that I evaluated. So we put the value of what? 0 into this function again. We have what? 2 bracket 0. This is power of what? 3. All over 3. Minus this minus here. You have 3. Anyway, see x put what? 0. Now we have what? This power of what? Power of 2. All of what? 2. Now we close the bracket. Now we have 2 to the power of 1 is what? 3 is what? This is what? 2 here. 1 is power of 3 is what? 1, right? All over 3 minus 1 is power of 2 is what? 1. All over what? 2. Close the bracket. Minus, come to this side. We have 2 here, right? Bracket. 0 to the power of 3 is what? 0. Close the bracket. All over what? 3. Minus 0 to the power of 2 is what? 0, right? Close the bracket. Now let's try to see expand it. We are not done yet. Alright, now look at this guy. We have 2 times 1 is what? Is 2. All over 3. This 3 here. Then we have here minus 3 times 1 is what? Minus 3, right? All over what? 2. Minus this minus here. 2 times 0 is what? 0, right? All over 3. All over 3. Then minus 3 times 0 is what? Is 0 all over 2. Now, at this point in time, let's look at the NCN. The NCN of 3 and 2 is what? Is 6. Know that 3 can go into 6 and 2 can also go into what? 6, right? So we take 6 here as their NCN. Now 3 going to 6 how many times? 2 times, right? Now 2 times this up the 2 on top of the 3 give us what? 4. Minus 2 going to 6 how many times? 3 times, right? 3 times is 3 on top of the 2, which going to the 6, give us what? 9. Then minus, come to this side, this is 0, right? 3 and 2, we can go into what? 6 abi. 3 go here is what? 2 times. 2 times 0 is what? 0. Minus 2 go here what? 3 times, right? 3 times 0 is what? 0. So we are going to have this become 4 minus 9 is what? Minus 5, right? All over 6. For the left hand side, minus. Now 0 minus 0 is what? Is 0, right? All over 6. 0 all over 6. At this point in time, we are having what? Minus 5 all over 6. Minus 0 minus 6. 0 divided by 6 is what? Going to give us 0, right? So this implies that our final answer becomes what? Minus 5 all over 6. This is how to evaluate this kind of integral using what? Definite method. Now let's look at integration by substitution. Integration by substitution method. Let's look at integration by substitution method. Now, in integration by substitution method, for us to be able to solve a question, you must know how to substitute a function. Let's look at example 1. They say we should evaluate the integral of sine what? X cos what? X dx. Now if you look at this integral, for us to be able to evaluate this function, you need to know how to substitute them and find the right parameter. Now let's look at that to solve this kind of question. Solution. They give us the integral of what? Sine x cos what? X dx. Now, you know that you cannot just integrate this function like this. It's going to be very difficult. So that's why I'm going to assume the method of substitution. So now, if you look at, you know that if you integrate, if you differentiate sine x, it's going to give us what? Cos x, right? So because of that, you say let u equals to what? Sine what? X. Now we are trying to manipulate this question. Let u equals to what? Sine x. Now if u equals to sine x, what you are going to find next is to find the derivative of this u, which is the u. We are deriving the function of this u with respect to what? X, because x is the parameter in this function. Now, for us to differentiate the u dx, which is going to be what? Cos of what? Cos x. Now, for us to differentiate the u dx, it's going to be what? Cos x, right? Because when we differentiate sine, it's going to give us what? Cos x. Now, we are gotten this guy, but look at our question. Our purpose of doing this is to manipulate and substitute this guy. This is what? The x. Now, for us to get the x, we are going to make the x the subject of the formula from this given expression. And for us to make the x the subject of the formula, we cross multiply. So we are going to have this become what? Du equals to what? Cos x du. Now, cos x dx rather, because this dx equals to this sign and this guy equals to this guy. That's why I have du equals to what? Cos x dx. But our major purpose is to make the x the subject of the formula. So for us to make the x the subject of the formula, we are going to make it to stand alone. And for us to make it stand alone, this cos x is going to divide both sides. So this guy is going to become what? Du over what? Cos x equals to what? Cos x dx all over what? Cos x. You know that now you can cancel out cos x from here, cancel out cos x from here, right? Remember what? This implies that our dx now become what? Which is du over what? Cos x. Now at this point in time, we have already gotten our what? Dx, which is this guy. Our dx is what? Du all over what? Cos x. Now let's substitute them into this function. Now the function we have here was what? The integral of what? Sin x cos x. Sin x cos x dx, right? But now we have gotten, you know that initially we said that let our u be what? Our u be what? Sin x. So this is going to become what? The integral of u. Because u now is representing our sin x times what? This is our cos what? Our cos x is still there. And now our ds is what? Our ds is what? Du cos x, which become what? Times what? Du over what? Cos x. I hope you are following. Okay, just that's nice. Now if you look at this guy now, you see that this guy cos x can cancel out what? Cos x, right? And we're going to left with what? The integral of u du. Now we are having the integral of u du. For us to integrate this function now, we're going to have for us to integrate this guy, the integral of u du. You know that integration we are adding what? This u now have an invisible power of what? 1 by the law of indices. Because anything is power of 1, same thing as that variable, right? So there's an invisible power of 1 here. And in integration we are adding what? 1 to the power. So this becomes what? 1 plus what? 1. You bring it down also, which is the power 1 plus the 1 that you introduced. Then plus our constant of what? Integration, which is what? Plus c. But that is not the end. But remember that our u was what? Our u was what? Sin x. Our u was what? Sin x, right? Now this become our final answer become what? Become what? Sin x put what? This becomes sin x. This power of 1 plus 1, right? All about what? 1 plus 1 plus this c. Now this become what? Sin this power of what? 2 all about what? 2 plus c. You can leave it in this form. This is an x. You can leave it in this form, or you can just bring, or you can bring it also as this. Sin 2x. Sin 2x all about what? 2 plus what? C. And this is the final answer of solving this guy using substitution method. Please, if you have any questions, you can drop it on the comment section. Let's move on to the second example on integration by part. Let's look at the second example on integration by part. Okay, let's look at the second example on integration by substitution. Example 2. So if you evaluate what? Evaluate the integral of 2x bracket what? X squared plus what? 1, right? This is power of 5 the x. Now this kind of question is somehow complex, but you need to understand the principle of how to evaluate it. Now for us to evaluate this guy, we are evaluating with what? By substitution method, right? Now let's look at how to evaluate this guy. You know that the derivative of this guy can give us this. That is the simple thing you need to understand. The derivative of this function inside this bracket will give us this guy. So now let's look at how to solve it. Solution. We have for the integral of 2x bracket x squared plus 1 this to the power of 5 dx, right? From here now we assume we have 2x bracket x squared plus 1 this to the power of 5 dx, right? Let me just assume the one that's inside the bracket. Since this guy can give us this guy, so let's just use the become what? Let's use the what? X squared plus what? 1. For us to differentiate this guy, we're going to have the u over the x equals to what? 2x, right? Now, the purpose of doing this is to find the value of what? Our dx. Now, if I differentiate this guy now, I've differentiated or getting what? 2x. Now, make the x the subject. Our dx become what? 2x dx. Now, for me to make the x the subject of the formula, I divide both sides by what? 2x. 2x. This cancels this. We are going to have this imply that our dx equals to what? Du over what? 2x. Now we are getting the value of our dx. Now substituting into what? Into the what? Function. Now we also substitute into this function. Now we are going to have what? This implies that the integral of what? 2x. Note that I assume that this x squared plus 1 being what? Our u, right? So this becomes what? Our u. All this value in this bracket become what? Our u, which is this guy. You know that the u is just the power of 5, right? Which is this 5. Now, times our ds is what? Our ds is what? Du over the 2. Du all over what? 2, right? Which is du all over what? 2x, right? Now, at this point in time, what are we going to do? See the manipulation now. See that this 2s can cancel out this word 2s, right? So we are going to left with what? Let's look at what we are going to left with. Now we are going to left with what? The integral of what? U is power of what? 5 what? Times what? Du. Now, for us to differentiate this guy, for us to integrate this guy, we will have what? When we integrate this guy, we will have what? U is power of what? 5 plus what? 1, right? All of what? 5 plus what? 1 by method of integration. Then we add our constant of what? Integration, which is plus c. Now, this becomes what? U is power of 6. Because 5 plus 1 is what? 6. All by what? 5 plus 1 is also what? 6. Plus what? C. But remember that our u, we said that our u is what? We said that our u is what? Function inside this bracket, which is going to give us what? 10 what? Sorry. X squared plus 1. This is the power of what? 6 all over what? 6 plus c. This is the shortcut method of solving this question.
Do well to subscribe, like, and share this video for more work.